What's up, guys? It's your boy Run Dumu. Aha! Subscribe to the channel. And today I'm gonna be covering something very special. Saying I've been learning Pygame. Like I started this channel about 2 years ago, and I took a break. COVID is in rough. I'm saying I've been struggling, financially, but I'm getting my shit back together. You know what I'm saying? So I'm just gonna cover the Sonic clone today, and I'll leave a link to the GitHub in the description. So if you're looking to create something similar, you can access it from the description. So I'm just gonna go over it like line by line, and then I'll preview it in the. I'll basically run the game, and then you can see how it looks and how it works and stuff. Like there are a lot of bugs in the game, but yeah. So I'll go over it line by line. So basically, I wrote about 4 Python files, each of them, sayings.py, main.py, spritesheet.py, sprites.py. And the purpose of this is basically just to make sure that the code is organized right. So you have the main.py, which runs the main game. So you can literally just click play, click the play button here. This is a Visual Studio Code. Sayings.py, this contains all of the game sayings, all of the ramps in the game, all of the platforms, the different platform properties, right? The physics, the colors, right? The background, and the different game properties. Also, like using this system to organize your Pygame games is probably one of the most productive ways you can go about doing that. And so this is obviously the sprite sheet. And so the sprite sheet basically makes it easier for you to access different images, right? So that you're not just loading each image one by one. And then obviously the sprites, this contains like, the different types of sprites in the game, the enemies, the platforms, Sonic himself, right? And the different types of controls that you have for each of the characters. So I'll just go over the each line one by one. So basically, like when I was building it, my whole mindset behind it was, how could I build this in the most efficient way possible? And so I decided to split it into 4 different files for each section of the game, the sprites, the game itself, and the different sayings. And so like I've written like a platform list, because usually you have some sort of like system that procedurally generates each platform, right? So that way there's like this sort of infinite world generation. But I'm inexperienced and how to do that. So I literally just manually added it. Now obviously I don't recommend this because as time passes, if you're building multiple levels in your game, you definitely want to figure out some sort of way in which the code can dynamically generate different platforms, and so you're not just adding the platforms manually. Like it was a very time consuming process. It took me like an hour, and there aren't even that many platforms to begin with. Complete fucking waste of my time. So anyway, I also added each ring in different locations. So this is basically just the this right here. This value is the X location. This is the Y location. And I tried to like figure out some sort of way, like if you're following my cursor here where it says ring offset, to sort of like when every ring is generated, right, it offsets the next ring's position by at least 50 pixels. And so I wanted to like dynamically generate like a set of 3 rings. Like, cause you know how in like the original Sonic, right, there are like literally 3 rings in like different places. And obviously that didn't work out, so I had to just write it a complete list, and the spikes themselves as well. The spikes, like working on the collision for the spikes was rough. you know, like there's a glitch in the game. Like when you download it, you'll notice where if you run into the spike, you sort of like get pushed back a little. And so I was trying to recreate that effect as when like when Sonic jumps on a spike and then he gets like sent back and then he becomes like he flashes. He sort of like becomes transparent and then he flashes and then the rings pop out and there's like this little ring sound effect. But it ends up just looking really weird. And so I was create like an enemy list. And that's basically just the locations for each enemy. And this is practically useless. Like I don't really like. Obviously, the player has his own jump. I'm trying to keep track of like the number of rings that he has, so I can update it. You know, this was really hard to make. You know what I mean? Like I've been doing this for almost 2 years, but it's sort of like been on and off. Like where I would spend months not doing any coding because I was just working on improving my financial situation. Like I'm not a very fiscally sound person, so now basically the game itself is an object, right? And that basically just makes it easier for you to access certain information, certain pieces of information from like the different files, you know. And so obviously I have my imports here. I imported the sayings, imported the sprites, imported the sprite sheet. I'm not even sure what the purpose of this is. I don't know why I have this here. So basically, usually when you're using Pygame, right, you want to initialize it. Right, you have to initialize Pygame itself. Then you have to initialize the sound, the mixer. And so this self.running is basically just it's like a flag, and a flag is basically just a true or false value. And I'm using that to basically make sure, I'm basically using that to test to see whether or not the game itself is running, right? So that, let's say if Sonic runs out of rings, right, I could just set this to false and then it will literally just stop the game. Or it will, give me a second. I could literally just set this to false and then you go back to the main menu. And the clock is just, like in Pygame there's this thing called clock.tick, and it basically allows you to keep track of the frames per second. And so this is basically just me creating like a clock object that can help me track the number of frames. And so the camera is it's a really interesting thing. Right, that's not really something that's specific to Pygame. There was a code that I literally found on Stack Overflow for this. Obviously, I don't want to log into Stack Overflow. You could just Google it. You know what I mean? And it really made like keeping track of Sonic's position on the screen easy, because it's like if you don't have a camera in the game, you're literally just gonna hit. Like if you have a window that's like a certain width, because the window here, and we have the window sayings, about 860 pixels. So once you literally go past 800 pixels, you're gonna lose track of the character in the game. So you definitely need a camera. And obviously, I'll go over the camera code once I hit the sprite section, because the camera itself is a sprite, which is a really weird, but I'll explain that later on. And so this is obviously the ring count. I'm not sure if I need this or not, but I spent months creating this, and so I've kind of lost track of a lot of things. But obviously, this is basic Pygame. You create a window using pygame.display.set_mode. You set the width, and also you can set a flag. And this is a resizable flag. So if I was to run it, and obviously this is the background music for the game. And so this function, def new underscore game, is obviously, it creates the all of the different properties. Like, I don't really know what to call it, but basically when the game launches, right, Python and Pygame collect all of this information, right, everything you need, right, the different animations. So literally every single image here is, you can literally see this, is literally the whole animation, right? So if I was to run it, so I know that you noticed the little blue square around Sonic, and that's an issue that I've been running into, where it's like I tried to set the color key, but for some reason it just didn't really, make that background transparent. But that's something I'm hoping that, I guess, someone who's familiar with, Pygame can fix. And so obviously, because I'm using the sprite class, right? So whenever I create a sprite, I literally turn every single sprite into a Pygame sprite. And so obviously, you need to make, like, whenever something happens, right, you need to update on the screen. So I basically added every single sprite to this group, so that way, whenever a change happens, it can literally just update the entire group, and so you don't have to update each individual sprite. But obviously, each sprite needs to have its own set of groups. So obviously, like, enemies have their own updates, right? Like, if the player runs, the enemies aren't going to run, right? They have their own functions, so they each have their own groups. And also, I set a group for the floor. And I forgot what my reasoning was, so don't fault me for that. And this is practically useless. I don't know why this is here. And so, obviously I needed to instantiate. I needed to create an instance of Sonic in the game so that I could, update his basically just whenever, like, the player is using Sonic, he's playing as Sonic, you need to update Sonic's position, right? If the player presses spacebar, right, you need to jump, right? And so instantiating Sonic really helps with ensuring that you can, like, if you already know Pygame, this is all stuff that you should already know. Obviously, this is the ground itself, and this is the background. And so, like, my goal here was to create some sort of, like, parallax effect, right? So, like, if you notice, if you scroll, you notice how the background, and so, like, that's something I've also been struggling with recently, because this was the whole project is really just experimental. It's like, of course, there are going to be bugs. It's like, I don't want you hounding me in the comment section talking about, oh, there's so many bugs in here. That's just how things are. Deal with it. So this is obviously, like, notice how I mentioned damn, close it. Like, I mentioned that because I didn't know how to procedurally generate rings and platforms, I literally had to add them manually, which sucks. So, well, I'll go through it. So basically, whenever you have a list, right, and you're trying to procedurally generate something, you can use something called exploding the list. And it's just like, there was a video that covered this, right, by Kids Can Code. I'll link to that video in the description. And he basically just explains how you can literally take a single value, right, and then that can represent every single item in the list. And so then when you create a loop, right, it will literally go through, it will basically explode that list, like literally just take every single value and then just spread it out. And so then what that does is it adds the ring, because I've set each value to represent R, right? So then it adds R to the rings group, then it adds the rings to the sprites group. Because notice how I mentioned sprites, like how whenever something happens to every single sprite, right, it updates automatically. So that's what this is for. And then I did the exact same thing with the ramps, platforms, spikes, and enemies. And then this here ensures that the background music loops infinitely, so that whenever it ends, it just plays back again. And then this, the run function is called. And that basically just represents this. And so the run function controls every aspect of the game, right? So like basic game development is you literally have a series of events, right? You update the game and then you draw the update, right? And so I didn't mention self-playing, but self-playing is literally just its own loop. Before, like, in order to make sure that the game doesn't crash, right? It has to run at first, load all of that information that I just mentioned, and then playing is literally just when you're actually playing the game, right? But it has to run in the background and install all of that information. Like, you pretty much get what I mean. And then, so obviously each of these are their own methods or functions. It's literally the same thing. And so basically the draw function, as it indicates, draws. So basically this fills the background with a cyan. So if you know what the color cyan looks like, it's literally just the same color as the highlight that I have here. And so when I added the camera to the game, right, the original sprite, what do you call it? Like when you're using Pygame sprites, there's a function, right, or a method where it's like sprites.draw, but that doesn't work with the camera. And so basically all sprites.update or sprites.draw or something. And what that does is basically it blits it onto the screen. And blit basically just means you take the image and then paste it onto the screen. So basically, in order to ensure that the camera is following what's going on with the sprites every single update, I needed to do to blit it manually, if that makes sense. So I literally had to just take each sprite in the list, blit the sprite's image onto the screen, because in the sprite section, you notice it has its own image. This is something that I might cover in another video. And then basically just apply the camera to it. And I'll explain what that means once I get to the sprite sheet. Once I get to the sprites file. And so this is obviously just you flip. It's like basically you draw. It's like if you're familiar with a flip note or flip chart, right, where you literally draw every single image and then you just flip it and then it changes slowly. It's like a series of animations. So that's basically what this does. My update, as it implies, literally just updates everything. So if the player moves 1 pixel, the game will update the screen so that it looks like the player moved 1 pixel. And this all happens almost instantaneously. So like that's what ensures that the game doesn't look clunky, right? And so I'll explain, because when you're updating the frames per second, you need to add that to the update section. And so I'm basically just trying to keep track of the because there's this thing where sometimes the computer's graphics, right, slow down, right? You might have multiple tabs open, or the internet connection might be terrible, and sometimes the frame rate will drop. So there's a concept in game development called frame rate independence, and that basically ensures that even if the frame rate drops, everything is happening at the same speed. So if a square or if a character in the game takes 5 seconds to move from one point of the screen to the next, even if the frame rate drops, it will still move from one point to the next in that same amount of time. Because when a game is dependent on the frame rate, if the frame rate drops, the game will slow down, literally meaning that that same character would take significantly longer to get from point A to point B on the screen because of the frame rate. So frame rate, in a nutshell, is literally just how long it takes for each frame to change. So if the frame rate slows down, then the game will slow down, and so that's what this is for. So I'll literally go through it line by line. So in order to obviously keep track of the change, you need to keep track of a specific point in time, and then you have to compare it to whatever change happens. Like, this is extremely vague. So basically, dt represents delta time, right? And that's basically just, it's a term that represents the change in time, the difference between one point in time to the next. And so that there's a formula where the last point in time, the point in time that you're keeping track of, which is now, right? You basically divide that by the frame rate per second and you get the change in time. Right, so you minus the current time from the FPS, and then you divide it by the FPS. And the main reason why I'm dividing it by the FPS is because pygame.time.ticks keeps track of milliseconds, right? So for every millisecond, for every second is like 1,000 milliseconds. It's like the value that last underscore time returns is more like it's in the thousands. So I have to divide it by the FPS to get the actual frames per second. And so here I'm checking if the delta time is more than 60 seconds. It resets the current time, and then it does the whole formula again. So that way, no matter what, even if it passes 60 seconds, it will always remain frame rate independent. Now obviously, like, there are some bugs that come with this, so I'll show you. Like, notice how the, like, that red square that was moving back and forth rapidly, that's supposed to be an enemy, right? But because it's moving around so rapidly, it's very hard for the game to keep track of, different things like collisions and stuff. So when the game was playing, you could see that Sonic was literally passing through Sonic, right? And obviously that's bad for collisions, that's a game-breaking glitch. So like, if there is a solution out there for this, please let me know. It would be very much appreciated. And this was basically just for the parallax, right? I was trying to figure out some sort of way to get the screen to scroll whilst the player was moving. Well, not the screen, the background itself to scroll, but I couldn't really figure that out. And so obviously when you add and so here is the delta time, right? So we calculate the delta time up here, and then you add it to the update section, and this basically ensures that the game moves at that specific frame rate. So this is basically trying to keep track of whether or not the player is standing on a platform, right? So in Pygame, when you're moving downwards, right, your velocity increases, but when you're moving upwards, your velocity decreases. So I'm basically trying to see whether or not the player is moving downwards, right? So if the player is moving downwards, then the game checks whether or not a collision has happened, whether or not the player is touching the floor. So this is why I added another group, a group for the floor, because you're testing whether or not there's a collision between a sprite and a group. Understand? Because there's different kinds of floors in the game, right? There are different kinds of platforms and stuff. And so then if a collision has happened, or if there is a collision, for each collision, check whether or not the player's position is more than the top of the floor, right? So basically, if the player is moving through the floor, and if the player is moving through the floor, set the player's position equal to the top of the rectangle, then set the player's bottom equal to its, set the bottom of the player equal to the player's Y position, right? Because initially, when this didn't exist, there was a glitch where every time the player touched the top of the floor, it would basically, it was jittery, right? And then obviously, you set the player's velocity to 0, because if the velocity is continuously increasing, right, it's going to keep trying to move through the floor, right? So when the player's velocity returns to 0, it literally heads back to this in order to check whether or not the player is moving through the floor. This is testing whether or not the player is touching a platform. So if a player is touching a platform, for each collision, because for every loop, every iteration of the loop, every time it loops, it has to update and check whether or not the player is touching the floor. Or else, if it doesn't, then you're going to see a lot of glitches where the player is literally teleporting through the floor, or the player is stuck in the floor, and that's a game-breaking glitch. And oftentimes you'll see in a lot of modern video games where sometimes you'll move through a wall, right? And it's mainly because there's an issue with this, the collisions. Right, and so the absolute value is just, there was a tutorial I went through. I can't remember what the channel was called. And because the platform has different directions, there's a bottom, there's the left, the right side, and the top. You literally have to check whether or not it's touching each section, right? The left, the right, top, and the bottom of the platform. And so this is the absolute value. And what that does is whenever a value, right, turns negative, so for instance, the player's position could be negative, and if you subtract that from the what do you call it? Because the platform's left side, alright, is, it's hard to explain. So basically, this is the player's the platform's left side, the position of the platform's left side. So like, in order to make sure that you're checking whether or not the player is touching its left side, you have to check whether or not its position is within a certain distance from the left side. So if the player is in one point, it's basically, what I mean. And so I'm trying to check whether or not that's less than 10. And so the absolute value, like let's say if this returns negative, it turns it into a positive. So that way it's between 0 and 10 pixels rather than negative X and 10 pixels. And it also checks whether or not both the absolute value is less than 10 and whether or not it's also the player's velocity is more than 0. So in other words, because the left side, like if the player is obviously moving right, so if the player is moving right and it's touching the left side, then set the player's position to at least 1 pixel away from the left side. Then set the player's position equal to the left side of its rectangle. Because when you're testing for collisions, you're using rectangles, like whether or not the player's rectangle is touching the platform's rectangle. And then set the player's velocity to 0, its x velocity to 0. So whether or not it's moving left or right to 0. And then the same principle applies to this. And also the same principle applies to the ramps. But the ramps are different. You see, now this is basically just, I'm not gonna lie, this is code that I borrowed from a channel called DaFluffyPotato. I'm not gonna take credit for this. I honestly don't, I really don't fully understand how this works. But I can basically just go through it. In a nutshell, it tests whether or not the player is touching the ramp, right? For each ramp, it sets the player's relative position, which is literally the player's x position equal to the x position of the ramp. So basically, which point on the ramp you touched. Because the player is also moving, the issue with ramps in Pygame is that you're moving both the player's x and y are updating at the same time. Because usually when you're moving forward in a Pygame, right, you're either moving horizontally or vertically. It's never both at the same time. And so with ramps, you're moving both horizontally and vertically. And so that's what makes ramps complicated. And so it's like if you're looking to learn how to do the ramps, if you're looking to learn how to fix the ramp, how to add ramps to your game, check out the Fluffy channel. It's a weird name, but he's basically, this is his code. And then the rings are obviously self-explanatory. If you touch a ring, it adds 1 to your ring count, and then it removes that ring from the list, because there's literally only a certain amount of rings, right? So it's I wanted to make sure that if you touch a ring, the ring itself would disappear, because if you touch that ring and the ring doesn't disappear, it will continuously add to the count. And so the bricks is really just whether or not the player is touching spikes. It's the same principle as with the platforms. And then after this, we literally update the camera, right? And so the camera is following the player, right? And so the whole purpose of this is to update the camera's position. And then clashes is when it touches the enemy. It's also the same principle as the platforms. And the events are each event in the game, right? The events are literally just whether or not the player does something. So if, for instance, if the player presses the X button on the screen, the close button, it literally sets playing to false and sets running to false. And the whole purpose of that is to end the game. And obviously I haven't added a main menu section yet, but that's something I'm planning on doing soon. And this keeps track of the current file path. And initially I wanted to create a map for the game. There's a maps file here, a maps folder. This is the maps folder. And it was literally just the X position for each platform. But it's not, because I mentioned that I wanted to procedurally generate each platform in the game, but that's not something I could figure out. So that's basically a redundant piece of code there. And then this is just, because the game is an object, you have to instantiate the game. And so whilst the game is running, you run new game. Okay, and whilst the game is running, you basically run the function that I mentioned, the new game function. And if the game isn't running, you obviously, end Pygame. And yeah. Let me get some water real quick. the game itself, right, is an object. So one of the things that I noticed was that because it's an object, right, it has its own scope. And because it has its own scope, it's very hard to access certain variables in the game. So you literally have to turn the game itself into a reference in order to access those variables in other classes. And so that's basically what this does. And this, obviously, it's if you're familiar with sprites, you obviously need this. You need to initialize the sprite function so you can turn this object into a sprite. And then each sprite has its own image. And so this is basically just, it selects a square or a piece of the sprite from the sprite sheet, right? Because there's a sprite sheet here for is it each? There should be a sprite sheet. Yeah. So this is literally a Sonic sprite sheet, as you can see, and this is the JSON file. And so each section of this JSON file represents a frame of the animation. And then here is obviously the rectangle. Right, this allows you to test for collisions. And obviously I didn't mention this before, but when I was calculating the player's velocity, right, it's a vector. And a vector is literally just a series of two values. And so in this case, it's the x velocity and the y velocity. And also the player has an acceleration, right? So that way, because when Sonic's running, he gets progressively faster. And so I need to add an acceleration there. And then jumping, this is just another flag to test whether or not the player is jumping. And to also, this is to test whether or not the player is standing. It's also a flag. This is a, like, before I mentioned the frame rate independence, it's the same principle, except this is just to test whether or not the player has, it's to test whether or not, it's basically to just keep track of the changes in the player, and that's for a specific function that I have down here that I'll get to. This is obviously to test how much time has passed, to keep track, this is to keep track of the current frames of the animation. When the player is moving left and trying to keep track of the left movement's current frames, is to keep track of the current standing frame, the current jumping frame, the previous standing frame, and this is also to keep track of whether or not the player is animating. Now, in the Sonic game, whenever Sonic is moving, if you press down, right, he turns into a ball, right, and he literally rotates. And so that's something that I wanted to do. But the effect that this highlighted part has is that it creates this. Let me just, forget that. Forget that part. I can't be bothered. So this is pretty much self-explanatory, but it basically checks whether or not the player is standing. It goes through each item in the sprite sheet, then it updates and animates the standing animation. So that's basically what this looks like. And this is the jumping animation as well. Well, one thing that was really interesting about this is that whenever the player is jumping, right, you want to make sure that they can't jump repeatedly unless that's a mechanic in the game. So in the Sonic game, you can really only jump once, and then you have to land and then jump again. So that's basically what this is for. Right, it tests to see whether or not the player is touching the ground, and then if the player is touching the ground, it moves them back up. Right, so you move into the ground, then you move back up. And so this is to test whether or not the player is touching the ground. Right, and if the player is touching the ground or they're not jumping, then the player can jump. But if the player is touching the ground and the player can't jump, then yeah, that's it. And so this is an index error, and the index error is basically just make sure that whenever the player is jumping, that they don't run out of jump animations, because the jumping animation is literally just a list, right? It's basically a list of different images, and whenever you're jumping, you typically tend to run out of images, because animations happen pretty quickly. And so the index error is to just make sure that the game doesn't crash whenever you run out of images for the animation. And so this is obviously the update section. Right, notice how you have DT here. This is to ensure that the player's animation is frame rate independent, right? And so whenever a player is jumping, right, there's an upward acceleration. And then, because when you jump, right, there's a certain speed you have and then it stops, right, because of gravity. And so when you're jumping, right, whenever you're jumping in a game or in real life, you're always affected by gravity. So it's a constant, right? And I added the value for gravity in settings. Where is that? Here it's 0.3. And so like this caused a glitch in the game where even if a player is standing still, right, the Y velocity is continuously updating, right, which is a pain. And that's actually a realistic thing, because in real life, you understand gravity is constant, it never stops. But it caused a lot of problems when I was trying to figure out how to get the player to jump. And so this is a basic, this highlighted part, keys equals pygame.key.get_press, is a basic part of keeping track of the key movements, the key presses. Right, so if a player presses right, the left key, they move left, and that means that the acceleration is negative, right? And this is to move right, and it's basically just the animation, right? This self-animate is the function that takes care of animating, right? This is the run right function. And I'm exhausted. This is obviously jumping, and this is to make sure that if there's no keys being pressed, then the standing animation should happen, because all of those values are here, basically, and this is just to test for friction, because obviously when you're running, right, if Sonic was running and there was no friction, he would literally just slide across the screen. And it's a very weird looking effect, and it's not very realistic. So I added some friction here. And this is just the equations of motion. I'm not going to go into that. It's a bit too complicated for this video. And this is just to make sure that, this is to make sure that you can't go off the left side of the screen. Right? It's almost like to create a sort of wall. Because you know how in most games there's like a boundary. And this is basically just to make sure that you can't go off the left side of the screen. And this sets the player's position equal to the middle of the rectangle, or the middle bottom of the player's rectangle equal to the position. Because without this, the player wouldn't be able to move. And this is just to ensure that as time passes, like I literally wrote it here, it's a speed feature. You get faster after you run for a certain period of time. Because in the original game, if you ran for like a few seconds, you would get progressively faster. And so here I wanted to make it so that the player would get 50% faster after 3 seconds. Like, it's a very hard effect to create because obviously if you're running faster, things start to blur, right? But like in the game, you don't really see that. And so this is just the background sprite. It takes care of, loading the background images. This takes care of, adding the ground to the game, the platforms, the ramps, the rings, the spikes, the enemies. And here comes the camera. Let me get some water real quick. Basically, this whole camera thing is really complicated. I'm not gonna lie to you. I copied this off of Stack Overflow. If you Google it, you could just find it. But I'll basically just go over it as best as I can. So this is a camera object. And what this basically does is that it adds a camera to the game, obviously. But the whole purpose of this is to keep track. This whole section, right, the initialization section, is to basically just keep track of the screen itself, right? So whenever you want to focus on something, you need to apply an offset. And an offset is basically just like the difference between one point to the next, right? So like obviously if you're following the player, right, you need to create this effect of following the player, right? And so the player's position is offset from the camera's focus. And so the offset location is in the top left. You understand? So the top left is literally just where my mouse is. Or at least the top left of the camera. Like, that's what that effect is for. As in this just obviously updates the camera's position, right? This keeps the player centered, right? It keeps the X position centered, because obviously if you don't update the camera's position, then the player will just go off screen. As in this basically ensures that the camera itself doesn't go off the screen. It ensures that the player's X position, no, the camera's X position is between a minimum of 0 and X, and X is obviously Sonic's X, and the Y is obviously Sonic's Y. So basically his horizontal movement and his vertical movement. And then it just turns the camera into a rectangle, right? That updates, and the rectangle's position updates using this X value and this Y value, and then its width and height, which is equal to the screen's width and height. And then the sprite sheet. Now this is also code that I borrowed from Clear Code. Yeah, there's a channel called Clear Code, right? And they have it has a tutorial on how to add sprite sheets to the game. So it's like, that's something I'll definitely link to in the description, saying I'm not going to claim credit for this because I barely understand how it works. I only really know how to use it, but I'll explain it to the best of my ability. And so basically when you create a sprite sheet, right, there are really only 3 things you need, right? You need a file, right, and you need some sort of way to access each part of that file, because the whole purpose of the sprite sheet is that it's one image that allows you to slice off bits of that image and then load that bit that you sliced off into the game. And so that's the whole purpose of that, is to basically just make the game a lot smoother. Because if you're constantly loading images into the game, right, you could have thousands of images, and that's obviously just going to slow down the game. And so basically here is you basically set the file name, right, you select which sprite sheet you're going to use. So in this case, this is the uh, Sonic sprite sheet right here. So this is the sprite sheet for the standing animation. And so what this does is it creates the metadata. Now, and the metadata is really just the data that's needed to load, the sprite sheet data. And so basically, whenever you, like the person who wrote the code, Clear Code on YouTube, he added a function where you replace the images file extension with a JSON file extension. And then what this does is that it passes that information. And so then, because when you're splicing or slicing a JSON file or a sprite sheet, right, it's literally just a series of squares, right? And so you basically need to set the X position for each section that you're looking to slice off for each image. And then what you do in order to load that information is you create a surface, right? And then you slice the sprite sheet, like you slice off that section, then you add that onto the surface, and then you set the color key. And the color key basically just ensures that the when you slice it off, right, it doesn't create this sort of like black square, like that cyan, that blue color square that you see whenever Sonic is running in the game, right? This basically just ensures that that's transparent. And then it blits the sprite sheet onto that surface. Right, so in other words, the sprite sheet image that you collected, the piece that you sliced off, onto the sprite sheet, and it places it in the top left corner at the X and Y position. But the X and Y position is basically just which part of the sprite sheet the image is, and this is obviously the width and the height of that image. And so the whole purpose of this function, the pass underscore sprite function, is to basically just slice off. Like, because when you're slicing the JSON file, right, you'll notice that there's frames, there's a name, and there's obviously like a specific frame. It's like, I'll literally show you what that looks like. And so you notice how you have frames, right? And this is the name of the file, and this is the specific frame, right? The pass underscore sprite function gets that information, and that's how you're able to obtain the sprite image from the JSON file. And so this basically organizes it so that for each image, because in the main.py file, you'll notice this, right? Self.s underscore run.pass, but this is literally just the game loading in the JSON file, finding the right image for each sprite, and then adding it to the game, loading it into the game. Now, it's obviously a lot more efficient, because if I was to literally just create each image and then load it into the game, that would be extremely time consuming, and it just wouldn't be very good for the performance of the game. And so then it turns that information, and so basically it assigns the sprites X, Y, because it's a JSON file. Like, there's literally coordinates. You can see that there are coordinates for each sprite in the sprite sheet. And so then what this does is that it assigns that to the X and Y value that's here. And then it basically just creates a new image out of the sliced sprite, and then returns that image. And because it returns that image, that's how we're able to get this value in the self.s underscore running variable. Notice how it's a list. Wow, that was long. And so that's basically how I created a Sonic clone. Jesus. I'm dehydrated. Yeah, if you have any questions, I know, leave it in the description. And obviously, I'm looking for help with this. This is an extremely difficult game to create, especially for someone like me who's a complete amateur. And that's it. And subscribe to the channel, man. Saying support me. I appreciate it. Thank you for watching.